For the second part of this lesson, we are going to relate the cosine law and sine law, also SOHCAHTOA, to bearings. So when we're looking at bearings, we're always starting from north and we go clockwise around. So 0 degrees is north, 90 degrees is going to be east, 180 degrees is south, 270 degrees is west. Basically, we're going, every one of these is a right angle, so we just keep on adding 90 degrees. 490 degrees is a whole 360. An example here is 60 degrees will be just over here. This line is 60 degrees, we're going from north. 270 degrees is going to be southwest, because it goes past the south and it's not quite west, so it's in there. Then when we look right here at 340 degrees, it's all the way around and we get in there, so it is northwest. So it's not quite north, but it's past west. And it's 20 degrees from north. Okay? So here is our first class example. We have two aircraft, A and B, leave an airport at the same time. And the course is, one is at 90 degrees, so 90 degrees, that's going to be due east, at 700 kilometers an hour. And the other one flies at 209 degrees at 600 kilometers an hour. So A says, calculate the distance each aircraft travels in 12 minutes. Well, if we look at this, this is in minutes, and this is in hours. So let's convert minutes to hours. So there's 12 minutes, and overall, in an hour, there are 60 minutes. So that's going to give us 1/5 hours, so 1/5. You could put it in decimals, which would be 0.2 of an hour. We continue this off. So we also know that velocity, or speed, is equal to distance divided by time. So if we rearrange that to get distance by itself, we know distance is equal to velocity multiplied by time. All I did was multiply both sides by time to cancel out the time. Now, using this formula, we could find the distance each plane traveled in 12 minutes. So we have, for plane A, the distance of A is equal to 700 multiplied by 1/5. The distance of plane B is equal to 600 multiplied by 1/5. And if we continue this, we'll find out that this one here is 140 kilometers, I believe, and this one here is going to be 120 kilometers. Okay? So now for the next part, it says, draw a diagram to show the position of the aircraft after 12 minutes. So after 12 minutes here, we go to the diagram. Let's make the diagram. So the first flight is going east. Just make my little north, east, southwest. Okay, it's going east, and that's 90 degrees. The other one is 290 degrees going, or 290 degrees going 600. So first one's 140. This distance is 140. And the next one is at 290. Well, 290 is just 20 past 270. Okay? Now, if I look at this, we want to know what is the distance after 12 minutes. So we want to know this line right here. Right there, we're looking at that line. How do we find that line? I know this is 90 degrees. And this here, well, what is this distance? If 290 is 20 past 70, well, that means there's another 70 here. This is 70 degrees. Or I could also go 360 minus 290, because this here, the total all the way around is 360. That's the closest one. Okay, which will give me 70 degrees. So there's two ways of finding this angle here is 70 degrees. Now, if I know this is 90 degrees and this is 70 degrees, I can figure out what this total angle is. That total angle is equal to 70 plus 90, which is equal to 160 degrees. All right? Now, it wants to know, calculate the distance in kilometers apart. So we're going to have to try and figure out which law to use. So we know there are two sides and the angles subtended between. As soon as we know that, we're going to have to use the cosine laws to try and find the third side. So I'm going to call this side here is A. So we have A squared is equal to B squared plus C squared minus 2 AC cos, and my angle here is 160 degrees, or cos A. So B squared is 140 squared plus 120 squared minus 2 multiplied by 140 multiplied by 120, and we have cos 160. Alright? So now when we plug all of this in, we're going to end up getting 200, or first of all, we get our A squared is equal to 65573.67. So then A, we must square root that, is going to be equal to 256 kilometers. Okay? So 1 to the nearest kilometer. Next one, question number 3. The diagram shows a section in an orienteering course which outdoor education students have to complete for credits. Now, starting at point A, the students go due north to B. So they go 9 degrees due north to B. Then they head to C. Now C is exactly 2.4 kilometers due east. So this is straight east at 2.4 kilometers. So north to east, that's a 90 degrees. Okay? Next, we take a look at this. And we also know it is at a bearing of 115. So if I made a little diagram here, we know that this distance here, oops, not all the way there, this distance here is, from here to here, is 115 degrees, because that's the bearing. Now we look down here, we're at C. At C they change direction at a bearing of 15 degrees. So let's make our little bearing. And we have 15 degrees. This is 15 degrees. And they go to D. Then from D they head back to B, and angle CDB is 40. So CDB, this is 40. And the first one says, mark the given measurements on the diagram. Explain why angle BAC is 90 degrees and why angle ABC is 65 and angle BCD is 80. Alright, so BAC is 90 degrees. That's the simplest one because this is due north and due east. So angle BAC is equal to 90 degrees because B is north and C is east. Therefore, they will be 90 degrees from each other. All right. The next one is we have angle ABC is 65. So we want to show that angle ABC is equal to 65 degrees. Well, so we're looking at ABC. This angle right here, it says is 65. Well, how do we know that? If I make this full extension, that's 180. So 115 and angle BAC must be supplementary because it's a straight line. And angle ABC must be supplementary. And if we look at that, if we go 180 minus 115, that is equal to 65 degrees. Okay? Now let's take a look at the last one here. We're looking and it says BCD is equal to 80 degrees. So we want angle BCD is equal to 80 degrees. So we're right here is BCD goes BCD. So saying this one here is 80 degrees. Well, that's fairly hard to find right now, but we know this is 15 degrees. And I think we could also find this here. This angle here is equal to, well, if we have 65, 90, and a triangle adds up to 180, this here I believe is going to be 25 degrees. Okay? Now, if I look at this here, this is 90 degrees. So 25 plus something, and then 25 plus, if this here is 90, and we minus 90 from 25, what do we end up getting? Oh, just wait, I might have made a mistake here. Is that 25? Sorry, this is 15 degrees, I believe. 90, no, it's 25, okay? Because we go 180 minus 65 minus 90 is 90 minus 65 is 25. So this is 25 degrees, and we have 80 degrees there, and we have 15 degrees here. Now, if we look at this, we're going to have from here to here is 90 degrees. So we go 90 degrees minus 25 gives me 65 degrees. Then we have to add this 15 there, plus 15, which will give me 80 degrees. Because this here is 90, so we're missing this part, 25 degrees, so that gives this part 65, then we add the 15 degrees, that's how we get that one. Okay, now it says, use triangle ABC to determine to the nearest hundredth of a kilometer the distance of AB and BC. So if we were to do this, we know triangle ABC, so we're trying to figure out AB right here and BC. Well, that's pretty simple. This is a right angle triangle, so we could just use SOHCAHTOA. And the first one, I'm going to use this side here and this angle. So if that's 65, and that angle, we're going to find the hypotenuse first. Or I'm going to use tan. So if we're using this 25, is equal to opposite, which is AB, over adjacent, which is 2.4. So it's 2.4 multiplied by tan, 25, will give me AB. So you just plug that in your calculator and you get distance AB. Now we're going to look at BC. Well, BC here is the hypotenuse. So we could do the same thing, except if I use this angle again and this side, you may have gone a different way of solving this. I'm going to use, so if we know adjacent, that's cos. Cos 25 is equal to adjacent, which is 2.4 all over the hypotenuse, which is our unknown, which is BC. So if we do that, we rearrange it, we're going to get the hypotenuse is equal to 2.4 divided by cos 25. Okay? Plug that into your calculator, and you'll get your answer. Okay, so the part C says use triangle BCD to determine to the nearest hundredth of a kilometer the distance of CD and DB. So I'm going to take back our diagram here. So we want to find CD and DB. So we're trying to find this side here, CD and DB. In order to do this, we're going to have to look at BCD, that triangle. And the two sides we're trying to find out are this one and this one. We know this angle is 40 degrees. We also know that this side here we found out to be a total of 2.65. I think from before, 2.65. So there's my 1 ratio. We also know that this here is going to be 80 degrees. Now, since this is 80 degrees, we can set up our sine, because we know this ratio and we know this angle. We also know that angle. So now we can set up our sine ratio. And first of all, I'm going to do, let's try right here. I'm going to use this one right here. I'm going to first do and find BD. So BD is equal to, we're going to use the sine ratio. So BD is sine 80, because that's angle C. And we're going to have here is equal to, well, we have the sine 40, because 40 and 2.65 are in relation. All right? So I'm going to end up getting oops, 2.65 multiplied by sine 80 and my answer is going to be 4.06. All right? Now, if this is 40 and this is 80, it adds up to 180, so that's going to be 120. Therefore, this angle here is only 60 degrees. Now that I know this is 60 degrees, we could use this ratio here. So we're going to find DC. So we have, oops, there we go, DC over sine 60 is equal to, we're going to have 2.65 all over sine 40. So we're going to end up getting 2.65 multiplied by sine 60 all over sine 40. And this is going to end up giving you 3.57 kilometers up in our calculator. Okay? Now the last one says calculate the nearest tenth of a kilometer total distance traveled in completing the course. So now what we have to do is figure out the total distance traveled. So they went up here, which we found this here. We found AB is 2.4. Oops, sorry, not 2.4. AB was, sorry, we have to find AB, which is a total of 1.2. We found AB, which is 1.2. They did 1.2 kilometers, then they did 2.65. Let's put that in. 1.2 plus 2.65, right? So 1.2, 2.65, then they went this way here. We found out DC is 3.57. And then after DC, they went all the way back down here, and this was, which is BD, and BD is a total of 4.06. So this is a total of 4.06. Okay, and if we add that all together, I'm going to end up getting 11.4 kilometers. All right? So that's how we do those. So good luck on your assignment. See you tomorrow as we tackle the assignment together.